All right, today we're diving into something truly mind-bending. It's an idea from a pretty speculative paper by Austin Maverix that tries to link physics, our own brains, and the entire universe with one single, kind of radical concept.
So let me just start with a question for you. A question that sounds like it's straight out of science fiction. What could possibly connect your own thoughts, the actual fabric of space-time, and the cosmos as a whole? I mean, they seem like totally separate things, right? But what if they're not? What if there's some kind of hidden language that ties them all together?
Well, the answer this theory proposes is, it's as simple as it is profound: information. The idea is that information isn't just something we create or use. It might be what the universe itself is fundamentally made of.
Now, this might sound like a brand new, wild idea. I get it. But here's the thing that makes it so compelling. Scientists, working in completely different fields, have been stumbling upon hints of this for years.
For example, in cosmology, some physicists have calculated that the universe has performed an astronomical number of computations on an equally huge number of bits throughout its history. In physics, you've got the holographic principle, which is this wild idea that our 3D space might just be a projection, that all the information in a volume is actually stored on its 2D surface, kind of like a hologram. And then, of course, there's neuroscience, where we know for sure that the brain is basically a very sophisticated information processor. You see the pattern here? The same idea, information, keeps popping up everywhere.
So how do we actually connect all these different threads? Well, that brings us to the very heart of this explainer, this new hypothesis from Maverix's paper.
It's called the Harmonized Informational Field, or the HIF for short. The proposal is that we should think of information as a fundamental field, just like gravity or the electromagnetic field, woven right into the fabric of reality. So at any single point in space and time, this field would have a specific value that tells you exactly how much information is concentrated right there.
To really get a grip on this, think about a weather map. Every point on that map has a temperature, right? A single number that tells you how much heat energy is in that spot. Well, the HIF is suggesting the exact same thing is true for information. Every point in the entire universe has an information value.
And here is the truly ambitious part of this idea. It suggests that everything that happens, and I mean everything, from the tiniest quantum particle interaction to a thought firing across a neuron in your brain, is really just a ripple, a disturbance in this one single universal field of information.
So what does this actually mean in practice? Let's take a look at how this one idea could, in theory, connect three vastly different realms of our reality.
Okay, let's zoom all the way out to the cosmic scale. Here, the idea is that the universe is literally computing its own evolution. The HIF could even be a potential candidate for one of the biggest mysteries in physics, dark energy. You know, that strange force that's pushing our universe apart? This theory speculates that the information field itself might have a kind of anti-gravity property that's driving that expansion. Now, let's bring it from the vastness of the cosmos right into our own heads. There's a fundamental principle in physics called Landauer's principle. It basically says that erasing information is not free. It has a physical cost. It must release a tiny but very real amount of heat. So if our brains are subject to this law, then every single time a neuron resets, it has to pay that energy cost. Thinking, quite literally, generates heat. And now, for the deepest level of all, the quantum world. This theory suggests that space-time itself isn't the fundamental floor of reality, information is. Quantum entanglement, that spooky action at a distance Einstein talked about, could be the very thread that weaves the fabric of space. So the more two particles or regions of space are entangled, the closer they are, literally defining the geometry of our universe.
Now, I know what you might be thinking. This all sounds a little bit like philosophy, doesn't it? But what makes this a scientific proposal, and not just a cool story, is that it makes predictions that we can actually go out and test in the real world.
And as Maverix says right in the paper, that's the whole point. The key is that the harmonized informational field framework has to make predictions that can be proven wrong. That's the line in the sand between speculation and a real scientific theory.
So how on earth could we test something this big? Well, the paper proposes some pretty incredible experiments.
For instance, could we build a calorimeter so sensitive that it could actually measure the heat released from a single neuron erasing one bit of information? Or what if we compared the large-scale structure of the universe, the cosmic web of galaxies, to the neural network of a human brain? Would we find spooky similarities? We could even search the cosmos for things that seem to break the known rules about how much information can be packed into a space. Or we could even try to build entirely new kinds of hybrid computers to see if they work the way this theory predicts.
This is that physical cost of thinking we just talked about, Landauer's limit. Breaking it down really simply, K is just a fundamental constant of nature, T is the temperature, and log 2 represents that single bit of information. This gives you the absolute rock-bottom minimum energy you have to spend to erase one yes or no. The neurothermal test is basically trying to see if our own biological brains operate right at this fundamental limit.
So let's just step back for a minute. If any of these tests actually found evidence for this theory, well, the implications would be absolutely profound. It would really start to change our whole definition of what reality itself even is.
Ultimately, whether this theory turns out to be right, wrong, or just a stepping stone, its real power is that it offers a unified framework. It gives us a shared language, information, to describe the universe all the way from the quantum realm up to the grand scale of the cosmos, and it places our own minds right smack in the middle of it all, not just as observers, but as an integral part of the system itself.
And that, of course, leaves us with one final, very provocative thought to chew on. If the universe really is just information, a kind of cosmic program running itself, does that imply that someone or something is reading the code? Is our own consciousness just the universe's way of observing itself? It's a question that really blurs the line between who we are and what the universe is. Thanks for joining us.